The sender-receiver system you saw earlier handles the many-to-many interactions between different objects. What about the interactions between the modules inside a single object itself? The very first rule when designing your object hierarchy is to have reusability in mind. This means that when creating the modules, you should be mindful about the dependencies you create between different systems inside the object itself. The way I tackle this problem is to use the main object node, the root node most of the times, as the grand mediator. This is why in the sender-receiver system, I made the receiver base call only the functions defined in its immediate parent, killing any chance of connecting it to any other module other than the brain. Having a grand mediator enables you to put all the object-specific logic inside the brain, keeping the functionality of different modules separate from the object using them. Let's consider a simple example. When the player dies, some sound is played, an animation is triggered, and some blood is emitted. The receiver informs the brain of what has just happened outside the object, and the brain then decides if it's gonna die, laugh, whatever. It acts as a mediator, informing the child modules to do whatever they are supposed to do. In this example, the blood emitter can be a reusable module with a wide variety of settings. What I just discussed may seem obvious to many of you. However, my approach is to go wilder on reusability. This way, just like a little kid attaching different parts together to come up with new toys, I can come up with new objects and even new game mechanics. Let's put this into practice by refactoring a simple character controller. Here I have some level and a player scene. Based on the character body 3D basic movement script, I've made a very simple controller. For now, all the logic is inside the root node. Let's separate things into reusable modules. You may actually not need to do this on such a simple object, but I prefer to use simplified examples to depict abstract concepts. To be able to modularize the object effectively, I ask myself what behaviors the controller has. Here is the list. It rotates based on mouse motion, moves based on keyboard input, and jumps again based on keyboard input. Each behavior is separated into two aspects, functional and conditional. This means that whenever some condition is met, some function is gonna be performed. Let's consider real-world examples. One may shout when one is angry. One may also shout when one gets severe pain. Here, being angry or having pain are the conditional aspects of the behavior. The shouting is the actual functional aspect. Separating the functionals from the conditionals enables you to elevate reusability to a whole new level. Now let's modularize our controller based on the concept I just discussed. Having a look at the code, I see that the major conditional aspect of the code is related to input, so I'm gonna make an input manager. I must think as generic as possible if I wanna be able to reuse my input manager in other projects. Let's make a new node and attach a script to it. We have action pressed and action released being checked again and again in the functions unhandled input, process, physics process, etc. So I make an array for each one of them. We need to create signals for them to be able to communicate with the controller. So I make a register signals function which gets an array and iterates through it, adding user signals based on the array element. Registering the signals inside the ready function, we are now able to check them. Please note that the name of each signal consists of the name of the action plus where it is gonna be checked plus whether it is emitted on press or on release. Let's begin with the unhandled input. Iterating through the array, I emit the signal with the appropriate suffix. Keep it in mind that we have two arrays here, one for action pressed and one for action released. The process and physics process look exactly the same. They just use different arrays. I know there are some other functions left to cover here, like input, but for now let's keep it simple. Having a look at the controller code, we see that we need jump and sprint actions to be added to the physics process list. However, when sprint, the shift key in this case, is released, we want the speed to get back to the walking speed. So we need to add it both to pressed and released list. We need to create the appropriate functions and connect them to the signal. Let's get a reference to the input manager and get it done. We can now safely remove all the sprinting and jumping logic from the physics process of the controller, and everything should work perfectly. However, I don't like the way I need to guess the suffix of the action and manually type it. Let's fix this by adding an enum to the input manager and updating the code to use the enum instead of the suffixes. This is not enough though, because now I have to write the name of the action plus the enum converted to a string, and this is ugly. So let's create a connect signal function in the input manager which gets an action name, an enum, and a callable as the parameter, and does the connection process under the hood. Adding a class name and changing the already referring code inside the controller makes the script editor give me hints on using the input manager instance. and it is working as expected. The good thing about it is that I can now use the same input manager class in all my projects and it will just work perfectly. Back to work. Now I wanna separate the mouse look logic from the controller because the mouse look behavior is something reused again and again in all kinds of projects. I'm gonna use the cam pivot as the mouse look module, so let's attach a script to the node and rename it. Here I have mouse sensitivity. I'll talk about the rotate parent thing in a second. Let's cut out the mouse look functionality from the controller and paste it inside the mouse look module. The cam pivot was the reference to the node, so we can delete it here. However, the first rotate call is supposed to rotate the controller itself, so we need to add parent dot. Everything is working as expected. However, I wanna add rotate parent option to my module to enable it to support different types of gameplays. Disabling the rotate parent checkbox makes the player's moving direction independent of the camera angle. And this is exactly the main point of this series. By separating the mouse look functionality and packing it inside a decoupled generic reusable module, you have the chance to enhance the system as you keep reusing it in new projects. Moving the camera to the center, you see that the same module can handle first-person shooters too. You can keep going and create the mover module, removing the movement system out of the controller. However, the movement here is so simple that it doesn't make sense to do so. You get the idea. But this is not the whole story. A central brain in your object managing completely independent reusable modules makes a lot more sense when you add state machines to the mix. Subscribe and hit the bell and don't miss anything I share. Thank you.